Good morning. Today, the second part of your lesson is to do these flowchart proofs. So we're going to use the ideas of CPCTC. On your worksheet here, you can see that we have two kinds of examples. One where I have this flowchart set up for you, and one where we're going to create that on your own. So I'll walk you through problems 1 and 3, and then you'll do 2 and 4 together. So just so we can see kind of different components of what proofs are going to look like, is you're always going to be given some sort of angle diagram like you have here in example number 1. So we're going to combine prior knowledge with things that maybe we already know. Something else we need to consider is that we have these givens in the upper left-hand corner here, and these givens are going to tell us some of the things, and we're going to use either the givens or information that we can see known about triangles to find the other things. On this last example, I wanted to show you that it didn't actually write out the givens, but that it did have a bunch of things labeled for you, and the labels are also considered given, so you will be able to fill those in. So the idea of these proofs is that we're always going to be following CPCTC. So that's why you can see that I have 6. Here, I'll highlight them and then erase that. But you can see that I have 6 boxes here, and those boxes are going to be our 3 sides. I also labeled those with the S's and the A's going down the center there, and that's going to get us to CPCTC, so that ideally that's what's going to go in the last box here. And so that is also a skill or a tip that students of mine in the past have used. This is called, we're trying to prove that these two are congruent. So in this last box is always going to be your triangle congruency statement. You're going to say that some sort of triangle is congruent to another triangle, but we will figure out what triangles are congruent as we work through this proof. So I always like to start with my givens, and I do my givens in 2 places. I write my given, angle J is congruent to angle P, and I like to go ahead and mark my picture right away. Angle J is congruent to angle P. That is an angle congruency statement, so I'm going to find one of my boxes labeled A and fill that in. Angle J is congruent to angle P. Good, so we got 1/6 of the way there. So I used this one. The next one, JK is congruent to PM. This is JK. This is PM, so I mark my picture. Those are sides, so I'm going to write that into a side box. JK is congruent to line segment PM. All right, I have 2 sides. One side and 1 angle. I have another given, JL and PL. JL and PL, so those are going to get 2 dashes. And again, I can write that into a side box. JL is congruent to PL. Okay, so I have 3 sides, and then I kind of run out of side and angle givens, but I am also given this bit of information. Angle L, or L, which is a point, bisects KM. So let me grab a color here. L bisects KM. What does that mean? It means it cuts it in half. So that's going to lead to these segments being congruent. So this one, that's why this one kind of has a step here. So point L bisects, what was that? KM. Okay, and that was what was given to us. And what that's going to do is lead into the fact that now KM, not KM, L, ML here and KL are congruent. ML is congruent to KL. And we want to be able to explain why. And the reason is that's the definition of a bisector, right? That's why we knew that. Definition of bisector. Up here, the other ones that we've done, those have all just been our givens. And we should write that in. Sometimes there's a line underneath our box. Other times I just kind of write it in underneath my box. You always want to be able to back yourself up and have a reason. And now we're kind of stuck because now we're out of givens. Let's look back at those givens. but the givens will always be enough, I promise you. But we've used now all 4 givens. So we would be stuck if we also didn't have this picture. So we know all of our sides are congruent. And one of the keys to successful proofs are looking for patterns. Well, look right here. I have 2 line segments that are crossing each other. These angles have a special pattern. Those 2 angles right there, those are vertical angles, right? So using our vertical angle theorem, and what we can see in the picture as it's given to us is that those 2 angles are going to be congruent. When I write this congruency statement, I'm going to say MLP. So it must also say KLJ, because you want to go short side to the middle to the long side, short side to the middle to the long side, like that. So what did I say? MLP and KLJ. MLP. Just like that. And the reason, remember before, was vertical angle theorem. Vertical angle theorem. All right, well, let's say, now we have side, 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 A. We need another angle. We have a theorem that tells us, well, if this angle and these 2 angles are congruent, well, then their third angles need to also be congruent. And that's just our third angle theorem. So it's going to be angle K is congruent to angle M. Angle K is congruent to angle M. And the reason is third angle theorem. And that is lovely. Now we are in a great place because now we have all 3 sides and all 3 angles either from the givens, in which we can just write given, but if we deduct it from the picture or it's coming from another box like our angle bisector here, we want to make sure that we use our rule. And once we have all 3 sides and all 3 angles, we can write our triangle congruency statement. And we can write this in a couple different ways. So let's just pick one of the easiest ways I think to do this is to go in order of the way you mark your angles. So I had J with 1, L with 2, and K with 3. And then I had P with 1, L with 2, and M with 3. So JLK and PLM. And the reason is going to be CPCTC. And that is a triangle congruency proof. Take the givens, fill them in the appropriate box, and then work off of the picture and from the givens until you get all 3 sides, all 3 angles. Make sure everything has a reason. And I encourage you to Google the reasons or ask friends about reasons and really try to come up with what we've done so far this year to see what makes sense. And then you're going to write your congruency statement and just make sure, just like we practiced in the notes, that your congruency statements match and everything's in the right order. For the next example, which is just example 3, since 2 is kind of scaffolded for you here, I want to show you how to do it in its entirety and work on the setup. And so when I set these up, I think that drawing out kind of those 6 boxes is going to be really handy. And you want to give your space on either side, just in case there's more to the problem, because it's not always just going to be 6 straight boxes. We could be given other information for our flow chart as well. And you don't have to put them in order of the side, 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 angle, angle, angle. And then we know that these 6, once we have these, that they will go to a congruency statement, which is going to fit right in here. But if you like to think ahead, we can say, okay, so side, 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 angle, angle, angle. And again, they do not have to come in this order, but if you're going to think that that's going to help you as you move through, then I'm totally cool with that. The next step is to go to your givens. We want to take advantage of these givens. They're there to guide us through the problem. We kind of do three things. We check off that we used that given. We mark it on our picture. So this is angle WXZ is congruent to YXZ. Okay. We mark our picture and then we're going to write it into our flow chart. And I'm going to pick an angle box. And that was WXZ is congruent to angle YXZ. So that is one angle done. They gave us another angle. XZW, so XZW is congruent to XZY. Okay, so let's fill in another angle. Angle XZW is congruent to angle XZY. So that's another angle. That's awesome that they gave that to us. Now we have two line segments. WX is congruent to YZ, so that is a line segment. WX is congruent to YZ. And WZ and YZ and remember, we want to do reasons. So each of these reasons is that it is given to us. And that is the end of our given. So now we have to use our picture or any other prior information that we know to help us figure the rest out. So right away, something I want you guys to always look for is your angles. If you have two of your angles, you can always find the third. If we know two of our angles are congruent, we can always mark the third angle congruent from our third angle theorem. So it's going to be W and Y. Angle W is congruent to angle Y, and the reason is the third angle theorem. So that is, again, something that I always look for, and it's going to be a really good trick. Now I'm missing a side, so let's look at the side that we're missing here. And it's this side right here. Well, guess what? A side is always congruent to itself. We need to say that XZ is congruent to XZ. And unfortunately, there's no third side theorem, but we're allowed to say that anything is congruent to itself, right? Anything is congruent to itself. XZ is congruent to XZ. And that reason is called the symmetric property. Symmetric property. That might be one you want to write down, and I'll definitely reassure that one over other videos. And so right here, we have three statements. We have side, 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 angle, angle, angle. And so guess what? We can finish this off by writing our congruency statement into this tiny box I drew myself. Our congruency statement is always that a triangle is congruent to another triangle. And in this case, it was triangle WXZ and triangle YXZ. And I'll show you why I chose those letters. There are multiple ways of writing this congruency statement, of course. We chose WXZ congruent to YXZ, and it just has to follow the right path here. So I went from WX to Z, and then I went from Y to X to Z. So you can see that it follows that same like mirror image pattern. So that's going to work. And something else that I just suggest is if you have an angle written in threes, you could just copy that angle, because if it's in a given, it's going to be for sure in the proper format as you move along, because they're not going to mess up a given for you. So just some things you want to check at the end, that you have your statement, your congruency statement, and that the order is correct. You want to make sure that you have one of each sides, one of each angles, and then do just make sure, and I'll pull my highlighter up again, do just make sure that each thing you have has a given or has a reason, because, look over here, I didn't write out my reason, and then I would not get full credit on this proof, because the reasons are really important. So even though you and I know that the reason is CPCTC, it's all about someone else being able to come in and understand your proof, because you could be a big math genius and figure something out, but if you can't fully prove it and have a reason why everything works, it means nothing. So just as important as filling in all the boxes is filling in those boxes with a reason as to why those boxes work. So you have two examples that you guys are going to try for homework. One that it's kind of written out, and the arrows just mean because this first, the first two are going to give you the third again for your angle because of third angle theorem. So that was just a communication bit there. And then you're going to try 4 all on your own. And remember, your givens here are from this. My answer key is in the worksheet guide for this for you. So I do encourage you to check and see your answers and such, but do give it a try, because proofs are something that where we're headed for the whole month of December here. All right, and these are flowchart proofs if you're doing some outside research. So have fun with these and enjoy.